Ang bayan nagmistulang malaking lawa na dahil sa baha.
Nagmistulang ilog ang mga kalsadang nalubog sa baha.
Navotas has more than 200,000 residents, some of them living in danger zones.
Glaciers are melting, sea levels are rising, droughts are more frequent, and extreme weather events more common.
Good day, jurors, mentors, professors, members of the academe, and my fellow blockmates. Today, I will be presenting my thesis proposal titled Liminal Border, a Biocentrism Time-Based Design through Liminal Spatial Analysis in Addressing the Episodic Changes of Sea Level Rise for 2050. Before I begin, I want to open up with a statement from Old Woman, a Dutch-German historian stating what happens when we approach architecture from the opposite direction, not aiming for the end product or even the perfect model, but rather from the development and viewpoint in time. Often than not, when we hear the problem of sea level rise, the common solution would be to relocate houses, elevate pathways, increase the barrier protection. However, the context of a border does not pertain to a single use, nor a single definition. This opens up the narrative where a norm can be interpreted into multiple definitions that varies based on its usage. It can be a separating construct, containment, enclosure, protection, and many more. Which begs the question, with the current growth rate of all the factors pertaining to sea level rise, how can a design archetype cover an ever-changing phenomena? Sea level rise is a tremendous threat that encompasses every paradigm we are concerned with. Before I go into the details of the study, I want to briefly run through the background on how the current scenario of sea level rise came about. The underlying problem shows that the timeline of how global warming influenced sea level rise started way back in the year 1500s to 1989. Shown in the projected emissions outlook explaining a 25 to 100 year temperature variations in a global scale, high levels of salinity cause drastic changes to terrestrial and aquatic life. More specifically, in the Philippines alone, there's a higher percentage loss of topsoils, denuded watersheds, vulnerable croplands, and an average deforestation rate of 28%. Global sea level based on RCP data analysis, where each RCP contains a unique set of socioeconomic assumptions that loops into natural systems responding to the overall warming of the global temperature. Based on the RCP scenarios presented, reflected in the graph is a factored socioeconomic representation that estimates the projection of sea level rise up until the year 2300. The study framework of sea level rise now focuses on the global and local lowland areas. Both the global and local setting contains mitigation solutions to sea level rise. For the global scale, the study focuses more on the observation of low countries such as the Benelux, Manhattan, and Holland, which all contributed and prospered from the ongoing and developed Delta works, setting as the main template for prevention. As for the local setting, most of the lowland areas focus more on the logistical aspect of prevention and control systems. Indicated in the chart show some of the changes due to sea level rise in lowland areas, which heavily affected the economical, societal, environmental, and health factors. Accelerations in the median sea level based on the tide gauge produce a 95% confidence level intensification. The increased rate of sea level produced by the satellite altimeters explaining ocean gauges movement that when one region rises, another decreases due to the typical 180-degree level line. Sea level change rates in an individual ocean basin deviates at an amount to the global mean as it is affected by relative influences such as current movements, atmospheric circulation, the Earth's gravitational field, and the influences of rotation axis. These are sample testimonials taken from various respondents and resource persons that contributed several insights and experiences regarding the worsening status of sea level rise. It is very evident that most of their insights revolve around having a continuous flow of climatic data and relevant prevention and mitigation schemes. Now, according to Dennis Bringas of the Chief of the Physical Oceanography Division at the NAMRIA, sea level rise within the area of Manila alone is rising 4 times faster than the global average rate. Considering that the Philippines is one of the most disaster-prone countries in the world that experiences flooding due to more than 20 typhoons a year, the acceleration of sea level rise will place densely populated coastal cities underwater and nearby coastal areas, which further implicates an increase of land subsidence scenarios and soil erosion issues. With the statement of the problem, the study focuses more on the intensification of climatic influences towards the year 2050, resulting in a continuous acceleration of sea level rise, threatening lowland areas, resulting with high-risk zones, and that the study tackles more on the potential threats of ground subsidence and its relation to the allocation of buildable areas and developing zones within the scope of the study. As for the research questions and objectives, research questions is divided into the statements of what can projection studies contribute to produce resilient strategies against episodic changes in sea level rise and the prolonged effects of global warming, having an objective of integrating an environmental analysis and probability scheme to delineate the focus points where the increased climatic conditions will have huge impacts on. Second, what outcomes can the development of water management studies contribute to the high-risk zones and vulnerable areas? Having the objective to explore hydrological water management systems to reconfigure the existing water systems of lowland areas. And lastly, how can natural-based approach on spatial planning redefine the geological borders of lowland areas in terms of the existing land use zoning and usage, having an objective of applying a multi-strata natural-based intervention that presents a suitable biocentric design approach. As for the research goal, the goal of the study covers the aspect of achieving adaptive context of spatial programming that promotes resiliency in terms of the programming, increase public accessibility, create a forefront of tourism magnet, re-engage the ecosystem outlook, and lastly, to build a communal space. To connect the liminal understanding of the problem and the time-based design intervention, let's delve into the application of the liminal theory and its complementing design analogies. According to Patrick Troy Zimmerman, liminality is a transitional threshold between two fixed states in a cultural rite of passage for dissimilar spaces in the architecture paradigm. In simplest terms, the theory of liminality can be understood as the in-between context. It can be situated in an environmental setting, user face setting, or within the surroundings of the built environment. Liminal approach challenges the current norms and situates the in-between context of it. The in-between context relates to several influences of time as a linear pathway. This involves one of the prolonging and worsening status of sea level rise, mainly due to the increased amount of global warming scenarios. Now, how can the in-between context deviate from existing solution materials and tackle on a new approach? Liminality presents preliminal, liminal, and post-liminal phases, where each phase conducts different modulation of activities. Under the preliminal phase, it is focused more on the idea of separation from what the current norm is. In simplest context, it is to start or instigate an act. For the liminal state, it reconstitutes that act taken in the previous state, which creates a transitional medium going towards to the post-liminal phase where it showcases a consequential paradigm of the preliminal and liminal, acting as a foundational platform towards incorporation. This model covers the spatial and contextual aim of the study, where it redefines itself as projection, progression, and reformation. Tier liminality poses a speculative approach where it stimulates a user and observer differentiation. For the user threshold, it aligns with liminal expressions of spatial and contextual reasoning, while as the observer threshold connects the biocentric approach towards the built environment as a new cognitive way of understanding. To concretize the process of liminality, polyvalent adaptation situates a design analogy that is based on a time-based development, considering various implications and reasoning for adaptation that ultimately culminates with the focus of language, logistical, contextual, and program allocation. The theoretical framework relays the scope of the study considerations regarding low-lying areas, which pans out to the theory of liminality of projection, progression, and reformation. Each threshold connects with the proposed liminal outcomes. For the study of episodic sea level rise, it highlights projection aspects that is achieved through probability schemes and risk assessment methods, which considers percentage predictions and pathway scenarios. Next, we have the macro and micro water hydrology process for progression, which focuses more on the process of containment and delivers the adaptation of existing systems to produce efficient collaboration between program and solution. Lastly, the biocentrism ideation focuses more on the reformation idea that tackles on the agroforestry studies and natural-based solutions that ultimately questions the meaning of the built environment and its purposes. The three outcomes ends with the intent to create proper space programming analysis, a dynamic contextual outlook, and a multi-strata natural-based intervention. For the first part of the conceptual framework, it shows the formulation of the theory of liminality in accordance to the outcomes of preliminal, liminal, and post-liminal. This correlates with the narrative of the lowland systemical and programmatic approach to sea level rise by interpreting the preliminal phase, liminal phase, and the post-liminal phase as a single and direct entity of design process. The liminal expansion then branches out towards the polyvalent adaptation of program allocation that route towards agroforestry and water systems that aims to achieve community engagement through the application of key strategies and benefits of the allocating the existing context of the lowland area. For the contextual, it enables the usage of both natural and program-based solutions that is attaining better circulation and mobility flow. Next, for the logistical, it relies more on the stakeholders and the establishment of relationships, which connects to the language approach, wherein each sector defines several key points of the proposal execution and the transition spaces between man-made and the environment. For the methodological framework, it shows the process of data allocation going towards proper research strategies of historical, correlational, and simulation. It then follows the delivery methods, concluding with the analysis and interpretation for the architectural intervention. Now, for the case studies, first, we have the New Meadowlands located at New Jersey, which focuses more on integrating a spine-like foundational system for transport and protection from future storm surges. Second, aqueous ecologies, where the use of parametrism is incorporated to locate proper branching points of the wastewater infrastructure that uses a polyfunctional and adaptive-based solution. Y-shaped jetty system focuses on coastal ecosystem protection, where it creates multiple spatial layers for future climatic changes. Big U by Bjork Ingels spans into different layers within the coastal area that protects the city from floods and storm water. LP Pichea, a wetland center complex that focuses on preservation and the conservation of mangroves, which also acts as a venue for an educational center. Lastly, the amphibious boulevard pavilions that reacts to an emergent type of habitation along the riverbank that blends itself to the surrounding environment. For the dialectics, the thesis explains that sea level rise places lowland areas as benchmark for liminal ideation in developing polyvalent adaptive scenarios for resiliency development. For the antithesis, it poses that intensification of the climate anomalies induce a drastic change and will negate adaptation techniques. For the synthesis, it entails a yearly projection of sea level rise that proactively uses a biocentric design approach of liminal expression through polyvalent adaptation techniques in lowland areas. For the thesis statement, the climate threatening outcomes of accelerated sea level rise posits that liminal expression as a design approach through polyvalent strategies of adaptation, covering a biocentric outlook of typological development, hydrological background study, and water management systems. This results in a viable environment that generates a circular economic lifestyle. For the scope of the study, it heavily focuses on the climate outcomes up until the year 2050, before the worsening status of global warming and its effect on sea level rise. As for the limitation, most of the data projection and analysis is also limited only to the lowland borders of the Kamanava area. For the study proper, a major contributor to the fishing livelihood was the 23 fishing ports of the Kamanava region, where it produced thousands of jobs and food security. This city is known to be a capital of market centers and other centennial parks located within the nodes of each region. The graphic is taken from QGIS, as 4 points were taken for georeferencing with a 50-meter interval for the contour shown. The graphic also shows the road, waterway, and coastal lines of the macro map of the site. Kamanava region is situated between the estuary and river deltas, which is one of the most densely populated coastal cities. The area is under a lowland plateau, which makes it prone to flooding scenarios that eventually weakened the soil stability of the Kamanava region. For the representation of the macro map, I use the tool of EPW script to attain the base map, relative humidity, sunpath, global radiation map, and waterway map. The proposed area of intervention focuses on the border side of Navotas facing Manila Bay. Strip border areas of Caloocan and Malabon that situates the intersection of Tulyahan and Navotas River. The site measures an estimated 180,772.562 square meter. Reflecting the updated comprehensive land use plan of the Navotas, Caloocan, Malabon, and Valenzuela, the zoning mapping indicates how most of the area covered within the proposed site consists of residential areas and few commercial spaces, and how the zones sprawled out way beyond the regional planning of the city ordinance that eventually caused an increase of sea level rise effects due to ground subsidence. Alongside the zoning study, here are some other pertinent mapping data that is relevant to the sea level rise phenomena. Topographic map indicating the variation of elevation between the cities of Lower Caloocan, Malabon, and Navotas. A liquefaction map showing the potentials of high and medium risk of soil weakening. And lastly, which is also related to the leading cause of liquefaction, the fault line map that plays a major role in tectonic plates moving and ground shaking scenarios. The initial SWOT analysis shows that the division of the four areas based on the sub-drainage of North Navotas, Catmon, Spine, and Bangkulasi. It covers high risk and low risk areas between the border, which eventually created guidelines and observations towards the intervention proper. For the design process, the direction of the design study follows through the process of projection, progression, and reformation as a key variable to the process of liminality through polyvalence. The design narrative focuses on how the liminal state of projection, progression, and reformation creates a singular and continuous project-based development. The polyvalent adaptation highlights the division of projection, progression, and reformation strategies from 2022 to 2050. Each section of the contextual, program allocation, language, and logistical approach varies on the loop-directed system that allows a repetitive information distribution from the users, observers, stakeholders, and other personas involved. It also uses the removal of elements to allow a filtering medium in recreating the textual studies of the design. To give an emphasis on the distribution of sites in the proposed area of intervention, as what the outline of the area insinuates, the areas are given identities of limit for Site 1, latch for Site 2, location for Site 3, link for Site 4, and lagoon for Site 5, showing that the name placements gives the hint of what their purpose, function, and contribution to the design development. Aligning with the liminal connection of user to the built environment, the proposed area of intervention is divided into 5 design sets containing different liminal connection properties based on their individual liminal conditions, pertaining to both the existing environmental context, boundaries, and the existing activities it holds. Further, in establishing liminal design sites, it is also imperative to study accessibility networks within the proposed site. Shown in the graphic are some of the major and semi-major roads that crosses the existing liminal conditions and boundaries of the study. The factor of liminality then crosses the compositions, zones, and transitionary elements, which is identified for each site within the proposed area. The liminal design sets go into the speculative process of branching a user-driven design, where the basic principles of elevation for lower and higher risk of flooding areas, merging the duality of the programs that the site contain, and lastly, attachment in enhancing the strengths of the existing site. The design principles considers the specific conditions of the site as shown in the programming below. The study allows that the previous liminal states to be applied into the site and to the parameter it holds. For each design set, the establishment of a liminal threshold between the users and the built environmental study situates these sample scenarios where it covers void spaces as visual connection, visual blocking of wall enclosures, minimal blocking of connection choices, and minimal blocking of a fixed choice. Next set, we have liminal connection as a moving persona, elevated spaces as visual enclosures, elevated spaces as visual opportunities, and elevated spaces as clusters. For the last liminal connection study, it contains natural elements as buffer space, infrastructural placement blocking, natural elements in a linear formation, and organic pattern of natural elements. The liminal ideation is not limited only to the site conditions, but to multiple disciplines as well. These are transport, aquatic programs, commercial, and residential areas, where in this study, the design analogy focuses on the contribution of the liminal border and its influence onto the stated archetypes. With the development studies conducted onto the liminal border, this design phase heavily enforces the process of a border connection, its coverage input, the process of overlaying, and water flow adjustments, as it is a vital markup, leading to the simulation of a growth channel study indicating several node points created along the corners of the border site, which intends to create and form organic channels, which fulfills the water flow objectives. The growth channel study is then adjusted for a water collision study in preparation for multiple scenarios of pluvial flooding, flash floods, and coastal flooding. Positioning the proposed site of intervention based on the given 5 design sets, the variation of each site correlates specific use towards the general layout and uses. It is divided into the channeling and redirection of phase 1, utilization and harvestation for phase 2, and diffusion and usage for the last phase. For the border design schematics, the study allocates the usage of an indirect impact analysis computation and land use availability to estimate a square meter per hectare allotment for each developing scope of the study. This promotes the use of the Navotas measurements as the baseline level since it is the most vulnerable area within the Kamanava region. Using the 5.46 square meter per hectare as a basis for the border iteration, the initial scheme explores divisions of land and water channels across several known shapes. The repetitive allocation of base shape, cross pattern, linear pattern, crisscross pattern, wedge side pattern, tapered pattern, contour pattern, and central fluid pattern is applied into 7 shape schemes. For the 10.3 square meter per hectare, this stimulates the study of program placement schemes where it tackles on the application of base shape, frame module, base frame pattern, center platform, catch basin form, terraformation, contoured pattern, raceway form, cross bracing form, semi-cross bracing form towards both the iteration models. For the 3.6 square meter per hectare, it focuses on the placement of covering utility measures, which is divided into 3 pod placement, reflexive canopies, and strip lighting. The following developmental schemes shows the water system ideation process, seawall ideation, and the development of the placement strategies shown earlier. This development study tackles on the initial placement strategies of 3 types and the topographical compositions, which is based from the configuration sets below. The following scheme compositions marks the allotment of the projected inputs and translated into the design aspect, where the first 3 shows alternative border layouts. As for the second set, it consists of typologies that promotes the use of frames and modular fabrications. And lastly, the last set shows iterations for the emergent structures of the development. Setting the scheme compositions onto the proposed site, this relates the conditions of their macro and micro use, where the design capitalizes on the 3 aspects of flooding and reinforces the typological and contextual placement based on the relevance of flooding indication. Shown below are the final scheme compositions that will foster and create the foundational background of the detailing and technicalities of the design evolution. Before proceeding to the design plans and schematics, here are some of the initial D-market models pertaining to the final scheme compositions of the design. Design plans and schematics. Presented in the graphic is the encapsulation of the macro development of the proposed site of intervention, where all areas have their own specifications as shown in the graphic, and all of the contextual use presented in the earlier slides of the design process were applied and developed further in the site master plan. The master plan pushes for renewable and durable material specifications and sustainable design efforts towards re-engaging the nearby community to the enhanced liminal border design. For the micro use of each site, the specific lot area coverage is shown and the total area combined of all the 5 sites allots to 58,783.09 square meter. The microsite development plans also shows the placement of structural foundational systems, proposed mobility pathways, commercial and retail typologies, and natural-based specifications pertaining to sea level rise, such as man-made wetlands, marshes, boardwalk conduits, soil placing, and more. Focusing on the nature and program-based narrative, the proposed design also gives a brief rundown on how the materiality and displacement of resources would be allocated for livelihood and energy purposes. The graphic explains that the multistrata connections is not limited only to the design analogy, but also to the overall context of the program, where it gives connection for pedestrians and dual opportunities for the locals, which is highlighted on the supporting design collaterals below. Further, the proposed circulation for movement and mobility gives the ability for the end users to have options in moving from one city to another, as what the liminal theory suggests, situating the border and using its developing construct as to connect people from different cities. Now, to tackle more on the specifics of the border design, zeroing to the multistrata border design, the proposed layout shows multiple growth channel connections, paving for water filtration, storage, and redirection for the border scheme alone. The detailing also shows the elevations of each channel, where the assumptions generate that water is free flowing. And the purpose of having the growth channel design on multiple levels is to increase the success rate of a better hydrological management within the parameters of the border. The border design also uses a pier foundation, which is commonly used for waterfront areas and riverbank structural specifications. As to give a more detailed take to the border material specification and use, shown in the graphic, the blue lines pertain to the fluvial, and coastal interventions of the water management. The graphic also shows how users can navigate through the design and how it promotes multiple usage of its design function, design elements, and allocation of materials. Focusing on the ephemeral structures of the design, the retail spaces of the proposal showcases the liminal interpretation of levels and view ranges, where it allows basic construction process for the common and to create configurations that are easy to develop into commercial strategies for the community. The design also caters as a threshold space as to give the separating identity from the old border design of Kamanava, showcasing its simplicity and non-destructive forms. The intricate placemaking of the structures onto the border entails a concept of permanence, where users of the proposal will experience liminal transitions from levels, open spaces, visual ranges, and mobility. The idea of the design is to maximize the limited space of the border and recreate the communal aspiration of a city and allow the users to navigate themselves onto the design as every program is aligned and connected to the actual planning of the proposal. Situating the scheme for the border iteration, the graphic shows a sectional perspective of the layers and elements under the composition of a typical lowland border area. Indicated are the systems and strategies applied into the context of the proposal. Focusing on the lower walkway portion, the sectional perspective shows a much clearer composition of design and technical elements devised in the lower site selections. Moving on, the proposal also introduces a small-scale mass transport infrastructure that will accommodate all the transportation and facility management of the proposal. It is designed as to set a walkable and open type space within the perimeter of the link site, connecting all the border design of the proposed area of intervention. The plan of the transport management oriented infrastructure entails basic space programming of ticketing stations and admin office for mass transportation mediums and for both transports and livelihood channels of the proposal. It also shows the proposed utilities of plumbing and utility layout of the design. The graphic shows the elevations and sections of the proposal, highlighting the division of spaces and how it resembles a split type design, allowing for a walkable upper floor for pedestrians and PWDs. Further, another sheet showing elevations and isometrics of the proposal, highlighting some of the vernacular materials of wooden slats and concrete finishes as to show the sturdiness of the design to contradict harsh conditions of the constant tide and sea level intrusions. Keeping in mind the border design systems, shown is a bay section detail and how the basic construction of the border would come about as it highlights the foundation specifications and material selections of the areas involved. It includes a blow-up detail of the tower design and how the construct can be configured in a vernacular sense. In addition, another base section detail of the mass transport building explaining the construction layout and material selection. The graphic also proposes the board design section where it focuses more on the water flow systems and how the contribution of the water management systems can redirect certain increase of water flow. Going back to the macroscope, detailing more on the framing of the lower and upper boardwalk of the border design, the sheet shows a simple frame design that will carry over the border iteration. It also includes basic lighting layout as to contribute to the landscape proposal of the design. With the detailed composition of the border, the analogy shifts onto the macro application where it is situated and adjusted based on the space programming and typological usage. It is very evident that the commonality of the design is based on strengthening the border's capability to handle and adapt intense water flow intake. The next graphic shows a detailed time frame based on the rotation years and some of the silvofishery components indicated in the design. Based on the coastal EDM simulation projection, each phase tackles on several uses that adapts to the various changes in level of water that then portrays initial water management schemes. Before concluding with all the given design technicalities, the liminal border will be a future template for a flawed, protected, and updated management strategy design of the Kamanava region, creating benchmark designs for each site as it holds individual identities of protection and local integration. For the limit site, here are some of the individual perspectives. Latch site perspectives containing lower site selections and boardwalk shots. Location site containing perspectives of the open areas and retail zones. Link site containing perspective shots of the mass transport. And lastly, the enhanced lagoon site, capping the liminal border solution. The study concludes with the importance of natural-based and program-based solutions that culminates with the appropriation of liminality towards problem solution derivation to adaptation and mitigation schemes in liminal thresholds, translating the in-between development of borders where the model settles within as a built construct in the effort of counteracting the episodic changes through the process of projection, progression, and reformation of a time-based design. Thank you.